Today we are going to talk about a cool thing. It is called volume. Now, what sets volume apart from anything else? Let's see what volume is. Volume is the amount of space measured in cubic units that an object or substance occupies. Okay, what the heck does that mean? Let's check it out. I'll go to my pencil here. Before we get all the way into volume, let's talk about dimensions. There's a line. How many dimensions does that line have? It has one dimension. It's one-dimensional. And if we measure that thing, we say, how long is our line? Our line is, let's say this line is 3. Oh boy, that's not the greatest looking 3 centimeters long, okay? So its units are in centimeters. Okay, now instead of a line, let's look at a square. Beautiful square I drew there. Imagine that's a square. Use your imagination. And that square has two lengths. So the length of this side is 3 centimeters. But the length of this side is also going to be 3 centimeters because it's a square. So now if we're to find the area of this square, we have to multiply the height times the base. 3 times 3, this thing has a area of 9. Now remember, 9 square centimeters, right? Centimeters times centimeters gives us square centimeters. Okay, so volume, it says, is measured in cubic units. So these are in squared units. These are just the single unit, centimeters, so cubic units. Well, to have volume, we're going to have to jump from one-dimensional to two-dimensional, and then you guessed it, three-dimensional. So, when we are looking at a 3D object, let's look at something like this. Oh, three-dimensional object, and we can switch our view and look. Oh yes, that thing actually has 3 dimensions. It has thickness to it. Very cool. Okay, so let's go look at this thing. Actually, I should move it a little bit. Oh boy. If I can move this thing, we'll rotate it a little bit this way so we can kind of see all its sides there. Hopefully you guys can see that pretty good. So now let's think about what our sides of that thing are. So we have our bottom side. I'm going to switch to black here so we get a lot of red going on. Now the bottom length here, let's say, is still 3 centimeters. And this length back into it, we'll say, is 2 centimeters. Okay, so this you can kind of imagine like a flat rectangle, kind of just like this square. So that square area on the bottom would be 2 times 3. But now we have our third dimension, and that's going to be our height. How tall is this thing? And let's say that this is 3 centimeters tall. Now to calculate our volume, or V, we are going to multiply all 3 of those numbers together. So it's going to be 3 centimeters times 2 centimeters times 3 centimeters. Okay. And that's going to give us our volume. So 3 times 2 is 6. Times 2, or times 3 again. 3 times 2 is 6. Times 3 again is 18. Okay. And our units now are going to be centimeters times centimeters times centimeters. We got 3 centimeters. So our units are now going to be centimeters cubed. So this thing has a volume of 18 cubic centimeters. And what I like to think about, let's go back to the definition here. It says an object, the amount of space that an object or substance occupies. So when I think about volume, I imagine that instead of this rectangular prism, which is what this thing's called, this thing is a rectangular prism. Instead of that, let's imagine that that top was open. Okay, so this whole area right here, let's call it open. So it's just like a Tupperware or something. And if we filled that thing up with water all the way to the brim, we would have 18 cubic centimeters of water. Now, we don't usually measure water in cubic centimeters. We measure water in liters, usually, or milliliters, but there's a conversion between cubic centimeters and liters or milliliters. So that's kind of that idea. How much substance could you put inside of this three-dimensional thing? If I stack that thing full of something, how much of that something can I put in there? That is volume. Now, a rectangular prism is pretty basic, right? It's this base times this width here times this height. But we can find the volume for a variety of shapes. What about a sphere? Let's switch our view. Let's look at that thing. That is a three-dimensional sphere floating out in space, just like the Earth is more or less a sphere, right? So we could find the volume for that sphere, and that's obviously going to be a little bit more complicated than a rectangular prism. But we can work through all of the equations. There are fundamental equations for every three-dimensional object, and all we have to do is think volume is how much stuff we can fit inside of something. That's what we're looking for. So whenever we're doing a volume problem, our answer should always, always, always be expressed in cubic length. Okay, it could be inches cubed, cubic inches. It could be centimeters cubed. It could be meters cubed. Okay, it could also be in terms of liters, big L, or milliliters. Okay, these are all units of volume. So whenever we have a volume problem, we're going to have three-dimensional object, and we got to figure out how much stuff will fill it up. We'll get more in depth into this as we go, but that's the introduction. That is volume.